Continuing the previous part, we are thinking of the difference between the length and breadth, right? So, in the previous example itself, if we want to find the difference between L and B, right? L minus B is true value, it is L minus B 3.08 minus 1.02, 2.06 centimeters. Now, error is equal to delta L plus delta B, which is equal to 0.03 centimeters. Now we are not taking the difference between delta L and delta B. It's not the subtraction. Here also it is the addition because we are thinking of maximum probable error. Who knows, length may be with positive error and breadth may be with negative error. So plus delta L minus of minus delta B may be positive. That's the reason every time whenever we are thinking of that error, right, that is 0.02 plus 0.01, it is 0.03. So finally you need to remember that though it is the difference, we are taking that error part as addition because we are thinking of maximum probable error, right? So finally the difference it is like this. Now take one more example. Velocity of A is given as 32 plus or minus 0.1 meters per second and velocity of B is 24 plus 0.1 meter per second, right? Now it is the calculation required to find out that relative velocity of A with respect to B. So we have already learned relative velocity of A with respect to B is VA minus VB, right? So we have spent more and more effort, more and more time on this one. As Aryan has expressed one doubt regarding that relative velocity, we have spent some time. So that relative velocity of A with respect to B is defined as VA minus VB. Now what is the true value? 32 minus 24, 8. What is that error in relative velocity? That is delta VA plus delta VB. This is the thing we need to focus on. Though it is the difference we are taking it out, though it is that subtraction, we are adding that error part because we are thinking of maximum probable error. So it is equal to 0.1 plus 0.1, 0.2. Finally, the relative velocity of A with respect to B it is 8 plus or minus 0.2 meters per second. Like that, we need to think of the relative velocity of A with respect to B. Next, before we think of the calculations of error with multiplication, division and that various cases, we need to focus on logarithms. We need to spend couple of minutes on that basics of logarithms. Most of the students know that if a power b is expressed as a c, if a power b is equal to c, then b is equal to log c base a. This is that basic definition for logarithms, right? So log c base a is nothing but it is b. Now second fundamental, log x power n is always equal to n log x, and log xy, if it is a product, it should be written as log x plus log y, right? And both should have same base a. So log xy base a is equal to log x base a plus log y base a. In the same manner, what is that log of x by y? It is log x minus log y, right? That is that fourth fundamental. Next, generally if we go for errors part, all that errors mostly will be calculated from differentiation, using differentiation. That's why we need to remember the differential of x log x also. D by dx of log x is always equivalent to 1 by x, right? And from that if I take this dx that side, d of log x is equal to dx by x, which is nothing but our relative error. Now if I replace with this d with delta, delta of log x is equal to delta x by x. This is relative error, right? Now in the same manner, remember the standard form, d by dx of x power n is always equal to n into x power n minus 1, and dv of from here d of x power n is equal to n into x power n minus 1 dx. This is a simple basic, right? And in the same manner, d by dx of 1 by x is always equal to minus 1 by x square. How it will be written like this? So we have the standard formula d by dx of x power n is equal to n into x power n minus 1. Like that, 1 by x can be written as x power minus 1. D by dx of x power minus 1 is equal to n into x power n minus 1. N is minus 1 here, minus 1 into x power minus 1 minus 1. So it is minus x power minus 2. So it is minus of 1 by x square. Like this, but we need to remember some basics regarding that logarithms and differential part.